All right, so I'm going to say a few words about ME 34000 today. Just a brief introduction of what this course is about and why it is included in ME curriculum. So oftentimes I get this question about why this course have to be in this class, in this ME mechanical engineering curriculum, and the answer to that is that the mechanical engineers work in a very diverse industry, and those industry involve measurement, and namely I would just say automobiles, aircrafts, ships. All of these mechanical engineers contribute to. Also manufacturing, and in each of those cases, basically there is always measurement, because for an automobile you want to have the speed up on your dashboard, and that requires measurement. For aircraft is the airspeed that you measure, and autopilot, that's driven off of that sensor data. So so it is a very critical component in ME curriculum. And one example that I give, that Air France jet that crashed on Atlantic in 2009, and that's because of the sensor icing problem. And that kind of tells you, if you do not design a robust good sensor, that has really a very severe consequences. So so what is this course? What does this course teach? Essentially, this course teaches three things in this particular curriculum, and that is, we'd like to know about measurement system themselves, namely sensors, signal conditioning, and the storage devices. And so in order for us to know we're getting the correct sensor data, we need to know the dynamics of these devices, including sensors and signal conditioners. That's one portion that involves 1/3 of the course. Then secondly, we also look at specific measurement types, for example, stress, strain, temperature, pressure, flow measurements. That constitutes 1/3 of the course. And lastly, we also look at the statistical variation in the data and see if we need to make adjustments to the measured data because of the variations, or you need to retake the data. So so all of this constitute this course. Also, we have a lab portion to this course, so that what you learn in this class, you also get to see some of it and practice it in the lab. In the lab, we do teach LabVIEW, which is a widely used software in the industry, and as well as their experimental labs. So we're going to go to the lab now and show you a few of those experiments. All right, so we're in the lab for ME 34000, and in this lab we have 4 different experiments, and I'm going to just show 2 of them. So here, right here, is called vibration measurement. So here we have this is called a shaker. There's a motor here that kind of moves up and down and shakes the beam here, this beam right here, and the beam is for a vibrating beam. There is different mode shapes that occurs on the beam, and at a certain frequency the beam is going to resonate, and it's going to have very high amplitude of vibration. So that is measured through a stroboscope that's lighting, and also you have meters here. They also measure the frequency of vibration. So that's one measurement that our students do here, that through a stroboscope, and compare with the data from that machine, and also they do some theoretical calculation to find the natural frequencies, and then make sure that their measurement value is correct. So that's one. Then we move on to this experiment right here, and this experiment is basically, it measures the acceleration of the beam. As you see here, there is a simply supported beam, and there is the accelerometer, it's a sensor that measures acceleration, That sensor data is processed. The sensor to signal conditioning device right here. From signal conditioning, it connects to a data acquisition board in the computer, and then through lab view on this computer, you can measure the acceleration generated by this beam. And the acceleration is initiated by this hammer right here. It's a tap, and that tap will essentially generate the acceleration, and that is captured through lab view, and also that vibration can be theoretically computed, that can be compared with the measured value as a verification. So this is some of the examples. For this lab we have a couple of more, but you get a sense of the class, how it's going to be theoretically as well as in lab.